In this lesson, we'll review an advanced math problem. We're on page 908, question 20, and I've attempted to reproduce the image. Not the best depiction, but again, just look in your book. We're told that all these line segments are congruent. They're all equal, and we want the ratio of AC, which is not shown, to BD. So if we're to draw AC, it would be like that. Pretty close. This is a perfect example. We know it's a level 5, and a lot of students don't get this, probably statistically only maybe 30%. And not only that, students who do get it right, the time constraint is another factor. This is a great example for using alternative problem-solving techniques, specifically putting in a value. Everyone works better with concrete terms instead of abstract terms. And so what I mean by that, we don't know the lengths of all the yellow lines, but we're told they're equal. All we have to do is put in a value. As long as you follow the rules, you will get the right answer. So I'm just going to pick a value. Any value will work. I'm just going to pick 2. 2, 2, that means BD, the whole length is 2, 2, and 2. Now, if they're all congruent and we're cutting it in half like that, you should recognize that each of these would be 1 and 1, and you'd also form 90s on each side. Right away, what type of triangle do we have? And this is why it's so important to know your special relationships. Anytime you see a right triangle with a 2-to-1 ratio, where the hypotenuse is twice the length of one of the legs, this is a 30, 60, 90. And again, you really should know these instantly. So 30, 60, 90. The small value is x, the 30, and the big value is 2x. All right, so in this case, we don't really need it, but this angle would be 30. This is 90, and this is 60, and the 60 is x root 3, so that our x is 1, this is just root 3, and this is root 3. Now, let's look at the length. We have concrete values for AC and BD. So AC, each one of these is root 3, so AC is 2 root 3, and BD, we pick 2, and now we divide each side by 2, and we end up with root 3 to 1. And the answer here is B. Isn't that a much better way of doing it? Any value, now you could have picked 4, you would have different values, but it would still reduce to root 3, 1 as long as you follow the rules. And while we're at it, I'll just give you the ratio. This is really commonly tested, and also 45, 45, 90 is the other special one. This one's a little bit easier. It's x and x, and then x root 2. And also keep in mind, if you have a square and you cut a square in half, that's supposed to be a square, and let's say this is 4 and this is 4, and then we cut this in half, you should recognize that will form 2 45, 45, 90s, and then x is 4, x root 2, it's going to be 4 root 2. All right, the answer here is B. See you next time. Thanks for watching.